Okay, hi, everyone. So, this is also a new lecture series, which is under chemistry, an aspect of integrated science. Yeah, we will be touching on acid, bases, and so on. Yeah, today. So, if you analyze what we use in our daily life. Um, for example, some of the drinks we take, some of the creams we smear on our body, and what have you. You'll notice that they are either made of a bit of acids, or they are basic, or they are made of salt. So it's important we get to know what these are, what an acid is, what a base is, and what salt is. We look at their properties, both physical and chemical. We look at their sources, okay? Yeah, sources and anything there is about these nature of substances. Yeah, it's very important because the WAEC exam sought to um find out your understanding under this very subject. Yeah, it's something that do come in the WASI exam very often. Yeah, so it's good we're touching on that today. So we'll, for the purpose of today's lecture, we'll do them. We'll start to touch on it one after the other. Yeah, so let's start with acids. Yeah, so acids. Okay, so um, before we begin, we have to look at the definition. So definition of acids. So let me, yeah, so definition of acids, yeah. And I want you to know that I ask questions randomly, so it's important you follow the lecture. So definition of acids. Right, so now for acids, three scientists propose a definition of acids. Yeah, so you can define acids according to each scientist's definition, and you will be right. What you have to do is to state that, oh, according to the scientist, an acid is defined as this. Okay, according to this acid, an acid is defined as that. Then you'll be marked right. Okay, so let's start. So three scientists propose a definition of acid. So we'll start with, so the first one we'll start with today is he's called Arrhenius. So Arrhenius. So Arrhenius came up with a definition of an acid. Yeah. Um, so we gonna look at what he said. Okay, so he said that an acid, an acid is a substance that produces hydrozonium, hydrozonium. Please check the spelling. So it's Hydroxonium. So that produces hydrozonium ions when dissolved in water. Yeah, so he said an acid is a substance that produces hydrozonium ions. In fact, let's do this. If you find some space, right? Hydrozonium or hydrogen. So if you see one of these is the same, okay? So hydrozonium or, madam, please, can they see my screen? Albertha, Christiana, can you see my screen? Mary, if you speak, I barely hear you. You have to speak out loud. You know where the laptop is, so speak towards that.
So we can hear you.
Not here per se. Can you see my screen? What I'm writing?
See.
Did I hear yes?
Yes.
Okay. Yeah, so hydrozonium or hydrogen ion. Hydrogen, yeah, ions. Okay, so I'll explain. I believe you are making some notes. Are you making some notes? Hello? What's going on? I can't hear.
Hello, sir.
Yes.
Yes.
Madam, I couldn't hear you. What did you say?
Can you hear us?
Yes, but sometimes I can't hear at all. Are they making some notes?
Yes, please. They are. Please.
Okay. Right. So, yeah, back at it. So, Arino said an acid is a substance that produces hydrozonium or hydrogen ions when dissolved in water. So, watch. So, this is a chemical symbol for hydrozonium ion. It's H, Mary, watch closely. It's H subscript 3, then O, then there is a plus at the top. So, if you see this, so this is hydrozonium ions. Hydrozonium ions. HYDROXONIUM. Okay. Then if you see this H plus, that's hydrogen ions. Any solution that produces H3O positive or H positive, that solution is acidic. Again, any solution that produces H3O positive or H positive is an acid. Now, let's look at some example of an arenous acid. So, of course, we're not going to write just the acid's name and then that is a no. For the example, we have to show with a reaction to better understand Arrhenius definition. Okay, so watch closely. So let's start with, maybe I should bring it down a bit. So let's start with example. Let's be fast. So let's start with HCl. So HCl is hydrochloric acid. Okay, hydrochloric acid. See, these things, just write it in some part of your note. Okay, hydrochloric acid. All these are popular questions that you can be asked. So yeah, HCl is hydrochloric acid. Now, so Arino said that if it is an acid, when dissolved in water, it dissociates completely or partially to produce what? H plus. Okay, it produces what? H plus, isn't it? So you're gonna have HCl yeah, so you're gonna have HCl plus water. You know, the chemical formula for water is H2O, right? Okay, so let's study this dissociation. So HCl plus H2O. Now, what is going to happen? Watch. So the cation in HCl, which is hydrogen, proton, would come and join the 2 moles of hydrogen here. So you end up getting H3O. And you know, H3O, if you see it anywhere, is a radical, right? It's a radical. It has a symbol plus on top. No one is forcing it. When you have 3 moles of hydrogen, 1 mole of oxygen, it's a radical. It's a radical. So the charge is positive, isn't it? Now, Mary, if H is coming to join H2O, what will be left here? What is left? What is left? Don't force it. Just be sincere. Something has happened. H has been moved from HCl to join H2O. What is happening? What is left?
Cl.
I cannot hear you.
Cl.
Yeah, so C, capital C, small l. In fact, what atom is this? Chlorine, right? Now you can see that in the chemical establishment, there is I've started to write powers, right? I've written the power for H3O. So the power for chlorine is also what? Minus. Alberta, are you following?
Yes.
Yeah. Now, what is happening in this reaction? In this reaction, you see, when you dissolve HCl in water, something is produced. What is produced? Hydrozonium has appeared, right? And I said any solution that produces HCl is what? Is what? Christiana, is an acid. Yeah. So that is it. So in exam, the question you see is that, oh, define arenous acid with an example, with 2 examples. So I've given you 1 example, right? You will not mind me, eh?
Sir.
Okay. I can give you another one. Ethanoic acid. Okay. Ethanoic acid. The chemical formula for ethanoic acid is CH3COOH. Ethanoic acid. Ethanoic. My machine is hot, so the writing delays a bit. Ethanoic. ETHANOIC. Okay. Ethanoic acid. It's an alkanol. Okay. The chemical symbol is Ca3COOH. Now, acids, of course, dissociate in water, right? Per Arrhenius definition. So that will be plus H2O. Now, let's see what's going to happen. What is going to happen? So the cation here, the H here would come and join to the H3O. At the end, what happens? Alberta, help me out. If the H come and join that, what will I get?
H3O.
Yeah, H3O. What do you think will be left? What do you think will be left? Oh, you can see it. Don't force it. Okay, we are not trying to memorize anything here. That's why I have not even chosen to use any book or something. I just want you to know that this is very practical. What is happening? What is left? You've removed H. So what is left?
CH3COO.
Okay. Please know that the numbers here is a subscript, okay? Ca3COO. So that's actually the anion, okay? Do you care to know the name? It's called ethanoate. Ethanoate. So CH3COO is called what? Ethanoate. But what is happening? Ca3COOH, I'm telling you, it's an acid because what is happening? After it was dissociated or dissolved in water, it's dissociated to form CH3. Sorry, it dissociated to generate H3O positive. Any solution that produces H3O positive is what? An acid. Are we here?
Yes, sir.
Let's do more. Now, I'm gonna, okay, let me give you one more example. Then I change it a bit by, showing you how all these are acids, so they can also produce the H plus. It's the same thing. We can do in a way to generate the H plus. So let me give you one more example, then I change the style for you. So we can use nitric acid, HNO3. It's one strong acid. So how did I call that? So I believe you will, when I write ethanol somewhere, you know the name, right? So HNO3. The common name. You see, in the olden days, the scientists had names, basic names they've been using to call certain compounds. Okay, we call that trivial or common name. You know, if you say trivial, it means common, right? I think there used to be a game like that. There used to be a game like that, trivial. Yeah, yeah. So yeah, yeah, yeah. So yeah, trivial or trivial means common. Trivial means what? Common. If you care to know the spellings, TRIVAL. Can someone check it out for me? Yeah, yeah. A no, so IAL, right? IAL. L, sorry. Let me write it. TRIVIAL. Can someone check for me? Because we're recording the lecture. We can't put wrong stuff on the media. Are you guys doing that? Christiana, are you not in the room?
Yes, I'm doing it.
Okay. Oh, this should, I think you are right. Anyway, so nitrate. Nitrate. Oh, come on, guys. It's fine. It's correct. It cannot be wrong. It's correct. Yeah, so the common name is what? Nitric acid, okay? And it also has a scientific name, also called the IUPAC name. Scientists, apart from, you see, the scientific name is long, so that's why they generated like a common name for it. Yeah, scientists have an actual name for this, okay? And in fact, if you ask, it's called it's read from the back, though that's not what I'm teaching today. But I want you to know, because for the purpose of this topic, I can even give you a setup depicting we preparing a gas, okay? Or yeah, we're preparing a gas using some kind of acid, and I can tell you the IUPAC name of the acid, and it's in the long run, I'll ask you to write some chemical equations, and it's up to you to reproduce or generate the chemical formula of these acids in order to establish the right chemical equation, left alone balance. So it's important you know. So the IUPAC name or scientific name, IUPAC name, okay? Some of you know. Can you help me out? It's normally read from the back. Mm. Alberta, can you try? Let's be fast today. It took almost all your time. I have barely an hour left. Alberta.
Please come again.
I
Your
want the
question.
scientific name for nitric acid. Read from the back. It's try. I've started. Will someone help? Mary. Why? Have you guys eaten? Madam has a lot of food. Go and ask her. Because you are all quiet. Eh? What's happening? Christiana,
7 minutes.
you are Googling it. Try oxonitrate. No one should use a phone in the classroom. Try oxonitrate. Okay, try oxonitrate. It's fine. I'll teach you these things. Don't worry. 5. The 5 is the oxidation number. I'll teach you that later. Triosonitrate 5 acid. The word acid because of the existence of the H hydrogen. Okay, so triosonitrate 5 acid. You will do that later. I just want you to know. So back at what we are doing, not to lose focus. Back at what we are doing. I'm saying nitric acid is an acid. Now it's up to us to prove. It's an arenous acid. It's up to us for us to prove, isn't it? So, of course, to prove acids when dissolved in water, according to Arrhenius, must produce A3O. Let's see what happens. So the hydrogen comes here. Mary, help me finish this up. Don't disappoint me. Or is it that you guys are writing and the lecture is a bit moving a bit faster? Madam, what's going on in the room? Can you advise?
That they are writing.
Okay. So they're busy. When you are done, let me know.
Done.
Normally, we add the nitric acid to the H2O. What will we get?
Yeah, so what is going to be the result?
H3O
Mm-hmm. Please hold on.
plus
Hold on. H3O positive plus what? Plus.
minus. NO3 minus.
Yeah, that's true. You see, all the time when the hydrozonium ion is already cation. Okay, so definitely what will be left will be an anion. Yeah. So you see, all these are Arrhenius acids, right? So if I ask you to define Arrhenius acid with an example, you can do this, okay? Now, if you're wondering, I mean, H plus, H, you see, now listen, if you're wondering, how can you form this to generate the H plus? I'm going to show you, but know how you're defining your Arrhenius acid. So if you are saying an acid is, well, some examiners may overlook, but here at Seekers, I want you to learn how to do the right thing. If you are saying an acid is a substance that produces hydrozonium ion, then your example should depict that where hydrozonium ions is produced, H3O. Then if your definition is saying an acid is a substance that produces hydrogen ions, like I said, some examiners are going to allow you, but I think if your example is producing hydrogen ions, that would be better. So alternatively, I'm showing you an alternative. So alternatively, the first acid I used was HCl. So you remember how we were doing that. Alternatively, you can do this. HCl, then you show an arrow. Then on the arrow, you can write water. So HCl, when dissolved in water, what will happen? It dissociates completely, all right, to produce hydrogen ions and chloride ions. So you see, I split it into two. Yeah, that's what dissociation is about. And you get what? H plus Cl minus. The other acid I gave you was ethanoic acid, C3COOH. So you show an arrow in water, it dissociates completely. And no, this is a weak acid, so it will definitely dissociate partially. Okay. And yeah, of course, you get to have CH3, COO minus, then what? H plus. The other acid we gave was nitric acid, HNO3. In water, it dissociates to produce hydrogen ions or proton, then what? NO3 minus. Okay? Yeah. Now, other examples of acid you can go and try at home. Let me use a different ink. Is phosphoric acid, H2PO4. You can go and try phosphoric acid. You can go and try a common acid called tetraoxosulfate 6 acid, H2SO4. So phosphoric, that's a common name. Phosphoric acid. Go and try it at home. Show that it's an arenous acid. This is also called sulfuric acid. And the way you see the name, quite simple. It should tell you that's a common name or the trivial name, isn't it? So your concern should be, what is the IUPAC name? You need to know. You need to know. So you can look for the IUPAC name. I can say it, but I don't feel like writing, so it doesn't become too much for you. So the first one is phosphoric acid or tetraoxophosphate. What would be the oxidation number? Let me see. That's like 2,1. Please hold on. Let me check something. Plus X. Yeah. Okay. Plus 4 times minus 2 0. Let's see. We have 2 plus X minus 6 equals 0. 2 minus 6. No. Sorry. 4 2 is 8. Okay. So 2 minus 8. Okay. X. Well, you don't have to see what I'm doing. Don't worry. That's minus 6 equals 0. Okay. So yeah, plus 6. All right. So yeah, the IUPAC name will be tetraoxophosphate 6 acid. Tetraoxosulfate 6 acid. Okay. Then the for that of sulfuric acid, that one is also tetraoxosulfate 6 acid. Yeah. Again, the first one, the IUPAC name will be tetraoxophosphate 6 acid. Then the second one, it will be tetraoxosulfate 6. So phosphate, sulfate, yeah. I don't wish to write it. So you can later go and play the video and you get it. Guys, so we're done with our arenous acid. Can we move on? Did I get a yes?
Yes.
So in exam, okay, if they say define acids, then you can choose one of the signs and then you define the acids according to the scientist's definition or postulate, okay? But sometimes they can specify, define arenous acid. That means you have to define acids according to arenous. I just felt I should let you know. So the next scientist that proposed definitions of acid was Bronsted-Lowry. And he's one of the scientists with the simplest definition of acid. So he said an acid, who knows? You can always try. Yeah. Who knows? Yeah. Hmm. Yeah, who knows? Yes, who knows? Okay, he said an acid is a proton donor. Do you remember this, Christiana? Do you remember this?
Yes.
Yeah. And proton, if we say proton is H plus, it's the same as hydrogen ion, okay? Hydrogen ion is also called proton. Yeah, it's also called proton. So yeah, that's what Bronsted-Lowry says. So in exam, they can ask you define Bronsted-Lowry acid with example. So example. So we can start with okay, the commonest, which is HCl, right? HCl. So yeah, HCl. So plus water. So we've done these already in the previous example, but I just want you to know, I'm come to show it. So you see, because HCl is an acid, yeah, it donates one proton, one hydrogen. I said proton is H. Yeah, every H has a charge of positive. So that's what I'm saying, H plus. Every hydrogen has a charge plus. Okay, so HCl, because it's an acid, it donates one of its proton. It donates its proton to water, isn't it? And that's what produces the H3O, isn't it? Then, yeah, of course, you'll be left with Cl minus. So HCl is an acid, right? Why? It's a proton donor. It's donating a proton. I've explained it to you. Mm. Yep. So yeah, the same thing applies with nitric acid. It's also a proton donor, right? How?
Yeah,
How?
it relates the proton, which is H.
Good. To water, right? And what are you getting?
H3O.
H3O positive then. Yeah, so it's a proton donor.
There's NO.
Oh, I'm
It's supposed to
sorry.
be
Yeah, NO3, yeah. Mm, I'm sorry, I'm coming. Oh, please hold on. So plus what? NO3. Yeah, so that is it. And you can do same with ethanoic acid, right? CH3, COO, CH3, COOH. So that also in water, what happens? Yeah, in water, what happens? Mm-hmm.
The ethanoic acid will donate H to the H2, making it H3O positive.
Yeah, H3O positive. Then we are left with what? Ethanol. Remember to include the sign, the symbol. Okay. Okay, let me know when you are done. And I gave you other acids as surplus. You can go and try that one. In fact, there are a lot of acids. For the purpose of this lecture, you get to know new or different examples of acids. But you can try with phosphoric and H2SO4. So the common acids mostly we give you is nitric acid, HCl, H2SO4, COO3, H. Yeah, it's very common. Yeah. Mhm. Okay. Okay. So let's look at Lewis. Just a moment, please. Okay, all right. Yeah, sorry, I had to react to a message briefly. Um, just a moment, please. Right, so let's continue. Yeah, so we looking at Lewis acid. Yeah, Lewis acid. Okay, so this for Lewis acids, we will not throw more light on it because at I mean for integrated science, you just have to know the definition. Yeah, but for art chemistry, then you must understand the examples it comes with. You must be able to illustrate with examples. Okay. So this one I'll just explain. So Lewis acid. Or no one worries your head with that. Okay, um so what is Lewis acid? So how did he define an acid? Yeah, so Lewis, sorry. Please hold on. Oh, what's going on with my machine? So how did he define an acid? So he said an acid is a substance that accepts lone pair electrons to form coordinate, covalent bonds. Yeah, to form coordinate covalent bonds. So yeah, according to Lewis, he said that an acid is a substance that accepts lone pair electrons to form coordinate covalent bonds. Okay, but yeah, when we talk of covalent bonds, it's bond sharing. Okay, you have this number of electrons. I need 8 to be full. Okay, I need 8 for my outermost electron to be what? Full. Okay, you have this number of electrons. Okay, then come and join yourself to me so that we share. Okay, that's what we call covalent bonds. Okay, it involves the sharing of bond pair electrons. Okay, just to assume the octet or duet rule. Okay, so that's all coordinate covalent bonds. And acids, yeah, and acids has empty orbitals to receive, yeah. So acids have empty orbitals to receive lone pair electrons. Okay, lone pair electrons to form coordinate covalent bonds. So that's what Lewis said, and Lewis acids are defined like that. Okay, so that is it. So now in exam, if they specify that to define acids according to Lewis, then you define as that according to Lewis, an acid is, if they ask you to define Brunelleschi acid, then you say according to Brunelleschi, an acid is. Now, if they ask you to define an acid without asking you to specify which, I mean, without asking you to define according to one specific scientist, then you have the option to define an acid from one of these. So that is it. Okay, we are not touching on business. We're still under artists, so I want us to throw more light on it a bit. Okay. So let's look at so let's look at these first. Let's define what strong acids are. Yeah, when we are done, I just want us to have an in-depth conversation about acids. Yeah, let's look at what strong acids are. Yeah, so strong and weak acids. So what is a strong acid? So let's write strong acids. My machine is warm, so writing to delays a bit. Yeah, so what is a strong acid? I think I said it in my previous writer. What is a strong acid? Anybody to try? Okay, so a strong acid is an acid that dissociates completely. So strong acids basically dissociate or dissolves completely, okay, in aqueous solution. Yeah, so So a strong acid is an acid that dissociates completely in aqueous. You know, aqueous solutions are more like water. Yeah, so aqueous solution to produce hydrogen ions or hydrozonium ions, right? Well, you can choose to add it up, or hydrozonium ions. Hydrozonium. Don't mind me, just listen to what I'm saying. Hydrozonium, okay? Ions. Yeah. Let's look at some examples of, okay, so Alberta, define strong acids again. I know you're busy writing. But if you heard me, what did we say strong acids are?
Strong acid is an acid that dissolves completely in aqueous solution to produce hydrogen ions or hydrozonium ions.
Ions, good. So just watch out. You can be asked. Okay, some examples of strong acids. So HCl is a strong acid. So hydrochloric acid. So look, I will need you to take note of the strong acids, okay? Hydrochloric acids. What's the chemical symbol? HCl, right? Another strong acid is nitric acid. The chemical formula is what? HNO3. HNO3. It's also another strong acid. Another strong acid is sulfuric acid. What's the chemical symbol? You people, you know. H2SO4. What other strong acid do you know? Phosphoric
acid.
Yeah, strong acid. So this one is also one. Phosphoric acid. I don't have space, so but the chemical formula I told you, I think it's H2PO4, yeah. So I've given you enough, right? So they are strong acid. They are very corrosive. Don't dare with them. So in the lab, we normally use them when they are dissolved. Okay. So these are common examples of strong acids. So let's look at weak acids. Weak acids. So can someone try weak?
They're active.
Mm-hmm.
They are acids that will not dissolve completely in an aqueous solution.
No, if you say they dissolve completely, then
Oh,
yeah,
yeah,
same strong acids. Uh-huh.
they do not. Opposite of
Oh, do not. Okay,
strong.
okay, okay, okay. Okay, so yeah, correct. So you say that a weak acid is an acid. So this is what we say that dissociate. This is the choice of words we use. Dissociate partially, okay. Yeah, we say they break down partially in aqueous solution. Okay. Aqueous solution. Yeah. To Mary, are you there? Mary. Okay. A weak acid is an acid that dissociate partially in aqueous solution to produce hydrogen. Yeah. Ions. Or hydrozonium what? Hydrozonium ions. Okay. So in exam, they can ask you define weak acids with an example. So you know. So example. So examples of weak acids. Yeah. So examples of weak acids are mostly the organic acids, okay? the organic acid. So I'm talking about your ethanoic acid. And today ethanoic. Yeah, you get to know a lot of them. So we have ethanoic acid, we have methanoic. So ethanoic acid is gotten from alcohol. We have methanoic acid. This is a kind of acid gotten from ants or bees. We have butanoic. All these are weak acids. So those organic acids that are gotten from plants and animal. Yeah, so we have butanoic acid. Yeah, that's the next subtopic we are coming to do. Okay. Butanoic acid. We have, yes, guys, tell me. Some of these names are familiar. Tell me one. Citric acid. Okay.
Lactic.
What did you say? Malic?
I said lactic.
Okay. You said nothing. Okay. Yeah, so lactic. Okay. Malic acid. Oh, sorry, lactic. Yeah, malic acid is also an acid anyway. Lactic acid. It's gotten from milk, breast milk. Oops. It's crazy. Mm-hmm. Yeah, so lactic acid and what? ETC. In fact, let's reserve the rest because we have other we'll be talking about organic and inorganic soon, and I'll overwhelm you with a lot of examples. Okay? Ethanoic, methanoic, butanoic, citric, lactic, etc. Guys, can we move on? Okay. So um let's talk about um sources of acids. Okay. Yeah, let's look at sources of acids, and then before we can talk about acids, their properties. Okay, how acids are. So sources of acids. Mm, sources, sources. Let me clean this. Sources, sources of acids. Yeah, sources of acids means where acids are gotten from. Okay, now we have, basically two sources of acids. Okay, we have organic sources. Yeah, we have organic, and two, we have what? Inorganic. So if I'm asking you what are the sources of acids, or where can acids be gotten from, then you just say that acids can be gotten organically or from inorganic what? Sources. Can we begin? Mm. So um or let's say sources or types of acids. So I'm choosing my words right. Mm. So sources or types. Let me use the word types. I'm sure that's what you see in your textbooks. Yeah. So types of acids. So you will see organic acids. So that when we are defining, we'll see that it's gotten from organic sources, and that one you will understand. Yeah. Then we have inorganic what acids. So now let's start with organic acids. You write a whole subhead, and then you write what is an organic acid. What is an organic acid? Mhm. Yeah. What's an organic acid? I've already said it. Yes. Mm-hmm. Oh.
Organic,
Uh-huh.
that possess the properties.
Oh. You're probably going too far. These are acids that are gotten from organic sources. I mean, what are the organic sources? Like plants and animals. I said it earlier. Okay, you're going too far. So these are acids. These are acids. Oops, why is it not coming? Acids, S. These aren't coming. Do I even have space? Okay, let me just introduce a whole new sub here then, so that I can have space to write. Yeah, so you are not wrong, but yeah, organic, yeah, acids. So one, organic acids, organic acids, yeah, organic acids are acids that are produced from plants and animals. Sometimes plant remains. Okay? Mm-hmm. Let me know if we can continue. Please, are you there? Mm. In place of produce, you can use the word derived. So they are derived from plants and animals. Okay? We will not even come and touch on inorganic acids first. So I want us to discuss more about organic acids. So you can write some, so a subheading. Okay. So follow the lesson. You see, we are forming our own like notes. So some organic. So I want us to like throw more light. Some organic acids and their sources. Okay. So I want you to know precise places we can get organic acids. Okay. When we are done with this, then we talk about inorganic acids. Okay. When you're ready, let me know. Let me respond to this.
Okay,
Yep.
if we are ready.
Thank you. So you know what we're going to write. So let's write two headings. So you write acid. Okay. Can I know the time in Ghana, please?
7:32.
Okay, so we barely have like 30 minutes left. Okay, acid. Then you write sources. Okay. Sources. Mind you, no, let me be specific since you are forming no. So you can write organic acid. Organic. Organic acid. Right, so let's begin. Let's begin. Yep. So we can start with, let's have ethanoic acid since it's the first. So you can get this from alcohol and vinegar, but I'm coming. So we can get this from vinegar. Okay. And alcohol. So the other ones, if I write, then you do it. Okay. If you know, you help me, like no stress. So the next one, I'm trying to give you as many as I can think of. Citric acid, yes.
Orange.
Orange, yeah. So citrus product. Mary, we said citrus product, okay? So since she said orange, yep, help me.
Pineapple.
Pineapple. Wait, pineapple. Please hold on. I'm coming. Okay, yeah. You see, yeah, that's what I'm saying. Yeah. So we can get citric acid from that, but the other sources of acids too you can get from pineapple. Yeah, you can get malic and ascorbic. Yeah, but well, I mean in smaller amounts. Okay. Anyway, we can still include that. So pineapple. Oops. Pineapple. Yes, Christiana, have you thought of any citrus product? Lemon, right? Do you agree with me?
Yes, sir.
Yeah, lemon, and what?
Tangerine.
Yeah, tangerine. Yeah, let's write it is because of space. So let's move on. You guys give one example. I want to use it first. You spoke about something. Malic, right? No, lactic. You said lactic. Yeah, lactic acid. Yes, where can it be gotten from?
Sir, animal milk.
Come again. Lactic. I can't hear you.
Milk.
Yeah, milk. Yeah. Okay, so lactic acid can be gotten from all right. So lactic acid can be gotten from you said warm milk. Yeah. Okay. Oh my machine. Okay, right. So now let's talk of ascorbic acid. So let's write them. I mean, let's write the acids down, then we'll look at their sources. So I want us to also talk about butanoic, butanoic acid. Let's write tannic acid. Let's write tartaric acid. Yeah, tartaric. I don't know if I'm spelling it right. Acid. I want to be sure I've not skipped anything. Yeah, tartaric acid. What's other acid again? Oh, metanoic. Yeah, metanoic acid. Did we write malic? Malic is not here, so let's include them. Malic. Malic. Oops. Please, I'm coming. This thing is misbehaving. So we have malic acid. Yeah. So that is it. So let me write the common ones I'm familiar with. Yeah, metanoic acid is gotten from ants and bees. This one is gotten from ants and bees. Yeah. Let's look at ascorbic acid. So apart from pines, there's a common one. Yes, ascorbic acid. Ascorbic. Okay, so yeah, right. So like I said, apart from pines, yeah, so you can get this from grapefruit. Some lemons. Yeah, and even oranges. So you eat it. I'm leaving you to go and do the rest. So go and look for butanoic acid, tannic acid, tartaric, malic acid. Okay. Please just refer to your textbooks and learn them. You need to know them. Okay. Guys, can we move on? So you have two assignments, right? Finding the sources of these, and then another one was about phosphoric acid and then sulfuric acid. I told you to write the chemical equation, right? Establishing that it's an arenous acid. Are we together? So you don't mind me again,
Please, yes.
Okay. I think you're busy writing. Finish and let's talk about inorganic acids.
Please, yeah.
Okay.
Are you not right?
No, someone is not done.
Yes, it's up.
Yeah, so Mr. Gilbert is good with, I think it's Greek or biology, one of them. So he will be teaching you that one so that I can concentrate on other stuff with you. Can I move on? And you have to understand, integrated sciences is an integration of other courses, okay? There is I read physician assistantship, so my field is more to biological stuff. Yeah, so it's the biology. Yeah, even though I have a background in all of these things, but a Greek like this, I can't teach it better than someone who did, an agricultural related program in the university. And so, yeah, I'll be teaching you biology related stuff, chemistry and physics. I'm cool with them. Yeah, then he will be doing that with you. Okay. Yeah. Can I move on?
Wait.
Okay. Cool. Please come again. This is how I should move on. All right, sure. So
Yes.
yeah, so if you watch, the next thing we have on our list is inorganic acid, right? So we would want to know what it is. So first we define it, right? I'm forming notes with you. So I think first of all, we defined it, isn't it? Then we looked at some examples here. So let's write. So the next is inorganic acids. Inorganic acids. Yeah. Okay, so these are acids. These are acids that are prepared in the laboratory. So while organic acids are gotten from organic sources, that's i.e. plant and animals, inorganic acids are acids that are prepared in a laboratory. Yeah. So examples here, no one will bother you about the sources here. So example of inorganic acids, we have example. So examples, we have HCl. Now you know their names, so I'll just write them. HCl is prepared in the lab. It's prepared in a lab. H2SO4 is also prepared in a lab. Yeah. My eraser is not even working on. Yeah. H2SO4. Yeah, it's also prepared in the lab. HNO3. You see, I'm making the lesson a bit simple for you by using the same acids you are familiar with. H2PO4 is also prepared in the lab. H2PO4, okay, it's PO4. Not even coming. Oops. Collapse. Please, I'm coming. It's not a good time, so I'm having a class. Thank you. Yeah, H2PO4 is also an acid. H2PO4. All right. So yeah, that is it about inorganic acids. Okay. Can we move on? Can we move on?
Yes, please.
Okay. So now another thing I want you to know, I'm just going according to the syllable. So I think that will be the last thing about acid. So another thing I want you to know is properties of acids. Okay. Yeah, properties of acids. Well, let's look at physical properties. I'll mix them. So physical properties, now you have to know when we talk about properties, let's say it's not happening, okay? But let's say Mary stole something from the office and ran away, like she's a stranger, and now we want to arrest her. When she was stealing, she came with a gun. It's Christiana that found her, right? Christiana have to describe her to us, her properties, how she looks like, isn't it? So that we'll be able to trace it. So it's good to know the properties of assets. Okay, so and we want to look at the properties in two folds, physical and chemical. Physical means what we can see or feel, isn't it? Then chemical is not what we can see, but the behavior it shows. I mean, when in reactions, okay, in the laboratory, when you using it in reactions, it's behavior. That's chemical. So in exam, they ask you to write physical properties. Ask yourself, the thing you are writing, or can it be seen, felt, or touched? Do you understand? Or even tasted? So one physical properties. So guys, can you help me out? You know them, yep. Yeah, I heard sir, right?
Yes.
Assets or let's say have sour taste. So a typical example is assets have sour taste. So a typical example is pineapple. Pineapples have acids in them. So that's why you take a pineapple and it has that sour taste, right? Next one. Most acids are liquids or soluble solids in water. Next one. Acids conduct electricity in aqueous solution. Yeah. Because they release ions. Because they release ions. Yeah. Another thing is how they appear on litmus. So acids, oh, what's going on? Acids, yeah, acids turn, oh, my ink is disturbing. Yeah, so acids turn, okay, acids turn blue litmus, yeah, blue litmus paper red. In fact, listen, you have to keep in mind the color indication of acids. I believe you all know litmus. Litmus is an indicator that is used to test the presence of an acid or a base, okay, or a salt in a solution. It's something we use to test if there is acid in a solution or a base in a solution or a salt. It's called litmus, okay. We have different colors of litmus paper. We have red and blue litmus paper. But I want you to know that acids, the color code for acids on litmus is red. Mary, the color code of acids, or maybe you guys are busy. Let me know when you're done writing.
Yeah, done.
Okay, so the color code of acids on litmus is red. Okay, so if you are bringing a red litmus paper to test an acid, if you are bringing a red litmus paper to test an acid, the color code of acids on litmus is red. So if you are bringing red, if you dip a red litmus paper in an acidic solution, it will remain unchanged because the color code of acid is red. So if you put a red litmus paper in an acid, it will still remain red. But the moment you bring a blue litmus paper, it will turn to red because I said the color code of acids on litmus paper is red. Mary, do you understand?
Yes, sir.
Guys, do you understand? Christiana and Alberta.
Yes, sir.
So don't forget that. So acids will turn blue litmus paper red. You can add up and red litmus paper. So yeah, and remain unchanged. And remain unchanged on red litmus paper. Yeah, and remain unchanged on red litmus paper. Right. Let's continue. Let's look at, yeah, please look through your textbook and add one more. Okay. I'm giving you a lot of work so that you can revisit your textbooks. I can't be feeding you with everything. Yeah, so number 5. So, and I remember every assignment I give you. So you do it and you send it to me on WhatsApp and I will be waiting. In our next lecture, you know how it is. I will ask you before I start. If you've not done it, you can't join the class. Even if it's not my class, you can't join that class. Yeah. Yes. I'm saying even if it's not my class, you can't participate in a class. Yeah, so it's important to do the assignment.
Sir,
Yes, madam.
please give me a minute. The period is finished. I'm coming to school.
Sure. Then I'm pausing the class.
Oh.
Okay, so because of the issue at hand, we're just gonna summarize what we did today. So today we define assets. We define assets according to 3 scientists definitions. Okay. Yeah, so we talked about Arrhenius definition of assets. We talked about Bronsted-Lowry definition of assets. Then we talked about Lewis definition of assets. I also helped you with examples under each scientist definition, so you get to have a clear view of what he explained. Okay, and I told you in the exam they can ask you to define asset according to someone with example. So we did that. Then we spoke about strong and weak assets. Okay, what strong assets are, what weak assets are with example. Then we spoke about types of assets. The types of assets. We said we have organic and inorganic. And we discussed that with examples. So that is it. And remember, with our organic assets, I gave you a lot of examples with their sources. Right. And now what we're on was physical properties of assets. And unfortunately, your light is off and we have to close. And our next meeting, we'll talk about chemical properties of assets, and that will be it. Then we'll start with bases, and our bases will go through the same style. We'll talk about their definitions and everything we did on the assets. We'll talk about the same thing. Then we come to salts. Right.
Okay.
So that will be it. I'm going to upload a lesson for you on your channel. Please do well to like if you're okay with that. If it's okay, if you're not okay, in that case, you can dislike it. And then if possible, you can share and subscribe to the channel. Until then, see you when you see me. Right, so I'm stopping.